What is up, everybody? Welcome to 8.3, the unit circle. Now, the unit circle is we've seen that it can do a lot of things for us. So, for example, it can the unit circle can make us calculate the sines and cosines of angles that are higher than 360 degrees or lower than 0 degrees, right? So the unit circle is basically a representation of sine and cosine on a graph, right? So we have ourselves x squared plus y squared is equal to 1, right? With our angle theta, if we have an angle theta right here, right? If we have an angle theta, sine theta, is equal to opposite over hypotenuse, which is x over 1, no, which is y over 1, which is y, and then cosine theta is adjacent over hypotenuse, which is x over 1, which is x, right? So sine theta is y, but cosine theta is x. So we can also, we can kind of manipulate this so that it becomes cosine squared theta plus sine squared theta, or cosine theta squared plus sine squared theta, plus sine theta squared is 1. But you can also write it like this, right? So cosine squared theta plus sine squared theta is 1, right? So we've seen those already. We've seen that fact already. However, now we want to extend the sine and cosines to not only right angle triangles but all types of triangles and all types, everything basically. Um, so what is the sine and cosine of 120 degrees? That question is it's a little bit out of our depth because we've only ever seen the sines of 30, 45, and 60 degrees, right? So and if they follow a really nice pattern, for example, sine of 30 is 1/2, and then cosine of 40, cosine of 45 square root of 2 over 2, and sine of 60 is square root of 3 over 2. So you can kind of have this pattern, right? Square root of 1 over 2, square root of 2 over 2, square root of 3 over 2. If you don't know the sine and cosine angles for 30, 45, and 60, go back to the 8.1 where I discussed how to get the sines and cosines for 30, 45, and 60. So what is the sine and cosine of 120 degrees, and how many radians is that? So if we can find the sine, we can find the cosine, because x squared plus y squared is equal to 1, right? So let's try to find it, right? So let's see if we can succeed. So 120 degrees is right here, right? And we said sine is the y-axis. So if you draw a line through this and this, what does 120 degree look similar to? It looks similar to 60 degrees, right? Let's change the color. It looks similar. Let's say this is theta 2. It looks similar to 60 degrees. So theta 2 is equal to 60 degrees. So theta so cosine of theta 2 is, we already, well, no, sine of theta 2, sine of theta 2, we already know that that is equal to, wait, give me a minute, sine of theta 2, freak, I am sorry, sine of theta 2 is, we already know that's equal to square root of 3 over 2, so we can deduce, since they're the exact same height, that sine of theta, you can look, since they're the exact same height, the sine of theta is equal to square root of 3 over 2 as well, right? And we can show in this circle right here, right? Analyzing relationships, use symmetry and other information to figure out the other points of the circle. So we can do that, and boom, they're the same height, right? cosine's a little different. It's a little whacker, right? It's a little crazier. So we have ourselves the sine is 60. We already know that, right? Sine 60. So the cosine, we can actually kind of just work it out in here, which is x squared plus 3/4. X squared plus 3/4 is equal to 1. X is equal to 1/2, right? So the cosine is 1/2, but if you look at this, it doesn't make sense for the cosine to be 1/2 because it's in the other side of the circle. So we actually have to make the cosine negative 1/2 in this case. So the cosine of theta is actually negative 1/2, right? And we're gonna expand on this later, not now. But let's go to the next slide. What's the tangent of negative 60 degrees? So same thing. Let's copy the diagram. Actually, I'm gonna copy this diagram. So same thing. We have ourselves negative 60 degrees is negative 60 degrees is a coterminal with 300 degrees. So this is basically negative 60 degrees right here, right? That's negative 60 degrees. So the angle is like this, theta. So what's the sine and cosine of this angle? What if you see 300 degrees right here, and then you draw a line down? It's in the exact same x-axis, right? It's in the exact same x. It's in line with the 60-degree x. Therefore, we have x is equal to square root of 3 over 2, and y. No, I mean x is equal to 1/2. X is equal to 1/2, and y is equal to, well, we can do our x squared plus y squared is equal to 1. So 1/4 plus y squared is equal to 1. So y squared is equal to 3/4, right? Y squared is equal to 3/4. And y is equal to square root of 3 over 2. But it's in the bottom, so we can't have square root of 3 over 2. We actually have to have negative square root of 3 over 2, right? So if it's in quadrant 1, it's always positive, positive. Quadrant 2, it will be positive, negative. No, quadrant 2 will be negative, positive. Quadrant 3 will be negative, negative. And quadrant 4, it will be positive, negative, right? And tangent is equal to x plus, is equal to x over y. Is equal to, no, y over x. I mean, tan is equal to y over x because it's equal to sine over cosine, right? Tan is equal to sine over cosine, which is equal to negative square root of 3 over 2 over 1/2. And if you want to do this, just subtract, just erase the bottom 2, and then you'll get negative square root of 30. That's the answer. So reference angles. We're going to talk about reference angles now. I don't like using the word reference angles because I do believe that all angles should be their own angle and they shouldn't have a reference angle on it. But the book likes using the word reference angle. So we'll use reference angles. But it's encompassed by the radius to the point in the x-axis. That sounds confusing. It probably is, but I'll explain to you what it is. So we're going to use the first example. What's the reference angle of 3 pi over 4? Well, 3 pi over 4 is, let me erase this. 3 pi over 4 is around, let's say, right, it's 135 degrees. 3 pi over 4 radians, 135 degrees, there you go. Right, that's theta. So, if you want to use a reference angle, you gotta have an angle that's less than 90 degrees, and it has to go from the x-axis. So in this case, it'll be this angle. So it'll be this angle. Let's name this theta 2, right? So the reference angle is theta 2, and there you go. That's the reference angle of 3 pi over 4. And the reference angle of 3 pi over 4 is, well, we know this is 135, so this is 45, right? This is 45. So that's the reference angle, 3 pi over 4. And with the reference angle, now we have our 45. We know what our x and y's are, right? So x is square root 2 over 2, and y is square root 2 over 2. But since we know that quadrant 2 is negative positive, our x is negative, right? This is equal to cosine, and this is equal to sine, right? and that's how you work it out. What's the reference angle 150 degrees? Well, you can just, I'm just gonna draw over this. Should I draw over it? Yeah, I'll draw. No, I won't draw over it. I'm just erase quickly. If my computer doesn't fail me, I'll erase quickly. There you go. And then do that. Okay, 150 degrees is about right there. Let's do a theta right there, and then this is theta 2. So that's the same reference, is the same reference angle, right? Because it's from the x-axis to the point. So you draw a radius to the point, and then the x-axis is encompassed by that. The closest, and it has to be less than 90 degrees. So this won't work because it's 150, right? That's 30. So we know our cosines and sines for 30. Cosine of 30 is negative square root of 3 over 2. Is square root of 3 over 2, and sine of 30 is 1 over 2. And since it's in the second, it's negative positive, so negative square root of 3 over 2 and 1 over 2. Right? What's the reference angle of negative 40? Well, we actually already got the reference angle because it's negative 40, so our reference angle is actually 40. It's pretty simple. So that's about negative 40 right there, right? It's big circle, that's theta, and this is theta 2. I don't think they use theta 2 in real math, but I'm just gonna use theta 2 just because it's simpler to visualize, right? And we can't find the sines and cosines of theta 2. However, sine of 40 is I guess about 0.6, and cosine of 40 is about 0.4. So no, it's cosine of 40 is 0.6, and sine of 40 is about 0.4. So there you go. That's for your information. So that's it. No, that's not it. That's not it. We still have a question. Find all 6 trigonometric functions of a triangle of hypotenuse as a ray extending to the point 3, negative 3. This is a little bit hard, partly in fact because it's not a unit circle, right? If it's a unit circle, we can just calculate it like bam, done. But this is not a unit circle. Unit circle means circle with radius 1. This circle's radius is square root of 3 squared plus negative 3 squared, which is 18, right? Square root of 18, which is 3 squared 2. This is the radius of a circle, 3 squared root 2. So but we can still find it. It still doesn't mean that we can't find it, right? It still doesn't mean that we can't find it. So find all 6 trigonometric functions. So we can use a fact right here. The fact is that tan and cot are nice, really nice, right? Tan is y over x, and cot is x over y. So we have our x right here, which is 3, and we have our y is negative 3. So we put tan theta. Tan theta is just opposite over adjacent, which is negative 3 over 3, which is negative 1. And cot theta is 3 over negative 3, which is also negative 1. Boom, done. Tan and cot. Sine's a little bit more confusing because 3 square, well, we have our 3 square root 2 over here. So our sine, if you've noticed, this is 3 and this is 3. This distance is 3 and this distance is 3. This means it's an isosceles right triangle. So this is 45 and that's 45. So you could just use the 45, but we'll calculate it the conventional way, and just in case that it isn't as nice as this, right? Because most of the time it isn't as nice as this. Sine is equal to opposite over hypotenuse, which is negative 3 over 3 square root 2, which is equal to negative square root of 2 over 2. And cosine is positive, so 3 over 3 square root 2, which is equal to square root 2 over 2. And CSC and sec is just the opposite. Negative square root of 2 and square root of 2. And that's it for today's episode. People are home, so I gotta end this episode. If you liked it, press the like button. If you need any homework questions, just put them down in the comments. See you next time.